Olá. Olá, Portugal. Tudo bem? You have no idea how it is like nice to be able to speak Portuguese in a foreign country, right? So I'm from Brazil, and I live in Berlin. So usually I just default to English all the time. I just came here in the airport, and I have this like amazing time, like people trying to help you, like speaking your own language. It's amazing. So hi, everyone. Thanks for coming here. I know that's the last talk of the day. It's pretty nice to see all of you here. I think for me, this is actually kind of a dream. I'm still trying to figure out this speaker thing. Like, that's quite new. So I'm so happy that you're here, right? So, yeah, like I mentioned, it's kind of unbelievable that I made it here. And I'm able to be here today to share a few things that I'm very passionate about. So I'm going to talk about modular federation, maybe something else. And I have a couple of events in lineup. I'm going to talk about them soonish when I have them figured out. So stay in touch. And the way that you can stay in touch with me, it's basically with my social handle. So that's also very easy. It's Vitor Alencar, Vitor M. Alencar, like this. It's the same one on GitHub, LinkedIn, Twitter, every social network. I'm very, very happy about it. I got to like save this handle. It's super nice. So let's go to the talk about module federation and how module federation is a game-changing JavaScript architecture. So before I start, I want to know the audience a little bit. So if I ask you, how many of you have heard about module federation? Can you raise your hand? Oh, OK, we might have a problem. Like, you know too much. There might be no surprises here. OK, I'm going to try to change things a bit. Super nice. I actually hyped to see so many people. Like, I did this in Berlin a couple months ago, and no one raised their hands, right? So I could talk whatever, and people would buy it, but now I feel the pressure. So please stay with me, OK? Right, so to tell you who I am, because I'm not as well known as Eddie Quendo yet. So hey, my name is Vitor Alencar, as you might know, and I like to start telling you why I do what I do, because basically, if you stop to think about it, speaking is pretty nice, like teaching is pretty nice, but it's also for free, so why I'm doing this? So I really like to help people. That's the core idea. I started in the dev community by people that helped me to find my way, and I want to bring this back. So I'm very passionate about to get people excited about technologies, right? Like to get them really like passionate about programming, whatever is the language, and get them to actually do something awesome. So because of that, right, every company that I worked kind of like plays a nice part into this. So I was helping the Brazilian educational, like I was working a communication startup for the educational sector. Pretty much everything that I do is trying to help people out. And now I'm trying to share more and more and more as much as I can with developers. I think this is my newfound passion, besides music. And this led me to a very amazing year. I'm very grateful to be able to, like I mentioned, I started last year. And it's crazy that I got to create a lot of content. I was invited to podcasts. So that's kind of feel totally unreal to me. So thank you all for supporting me on this. And again, if you want to follow my content, just follow me on social media. And please take pictures of the talk. That's also very appreciated. OK, but let's start. So I would like to start asking you the question, why micro-frontends, right? I'm pretty sure that all of you might know about microservices. But in the front-end space, I think there wasn't an idea that was kind of similar to it until somehow recently that you divide your front-end into an architecture that can be parallelized. So micro-frontends, they kind of borrow this idea from the back-end of microservices. And they put their own spin around it. So it's not one-to-one comparison. Don't think like that. But it's about how you can scale your application with big teams in parallel, work in parallel, enabling you to test new technologies, to deploy things in runtime, and be very efficient with your deliveries. So companies that use micro-frontends, I think you probably know all of them, and hopefully, I don't know if you work in a company, if you get to work with those tools, I will be very, very happy. But you have very big corporations always finding out that they have the same problem. They grow to a point that everything that they want to do kind of involve all the teams, right? So just imagine, you all know React, and let's say a company like Spotify, they use React, but they want to update the version, right? If they don't use a setup that allows them to do that, they're going to have to update React for the whole code base. I'm pretty sure that you can think how big Spotify is, or Netflix. That's not an easy task. So how we break this down into a way that we can have different teams working with different things and be agile still. Right. So this is the kind of a transition, right? Like that you take your monolith front end, right? If this actually exists, and then you break it down to smaller front ends. They're composable. They can run on top of each other. They don't bump into each other, and they share things. So that's the most important part, like that they can share things. Because I think this is the biggest problem that we run into every now and then in our companies at some point in scale. So the idea is very similar, that you want to enable like different teams to be very focused on a part. Like, let's say Spotify, there's people I know that they work just on the player or just in the like button because there's so much business logic attached to it, right? And you need a big team to make sure that you're delivering. But how you do that, if you have to depend like in 12 different people. So this idea is breaking this down and allow you to deploy things independently so you don't depend on the whole application be like built so you can actually do stuff. And the domain separation here, I think it's the most biggest superpower because now your team can focus on only things that actually matters to you, right? So you reduce the gap a lot and you get to synchronize only things that you think is important. So if you get anything from my talk, I would like to point to this slide and say, okay, micro-frontends, they are about scaling teams, right? This is very, very, very important. Very important, because people get excited about this talk, and they come to me and say, hey, I want to bring this to my company. It makes a lot of sense. We have a lot of dependencies. And then I ask the question, okay, how many developers do you have? 4. I say, okay, this is not what I'm talking about. So that's like companies to medium to big scale, like that makes sense. But if you're a small team, that's a lot of overhead. So this is just a warning. I'm very happy that you're excited about. But think about this. It needs to make sense for the team, not for the technology itself. So let's start with sharing code. I'm pretty sure that all of you would agree sharing code is hard. Like we have invented so many ways to do it, so many different strategies. And all of them, they have pros and cons, like everything in life. But it's always feels bad that you cannot have all the capabilities that you want, or at least most of them, when you're trying to share code in your company level. And usually it goes like this, right? So if you look what are the options right now, they always fall into 3 different sets, basically, where you have, for example, here, that we have a shell, like a big application that has a header and a footer, and I want to share this with the checkout team, for example. The checkout team is very busy. They work in different stuff. How we do this? What are my options? The first one is pretty obvious. You basically, what you do, you just go to the middle here, and you create an NPM library. I think we all have done that, right? And that's going to solve the problem in a short term. But then what happens when the checkout team is using a version and you want to update the version? Because the host team is actually responsible for those 2 assets, but the checkout team is also using it. What do you do, right? Can you imagine that now to have the version 1.0.1, everyone has to update? Otherwise, you run into legacy code, and you run into surprises along the way when you figured it out that your dependency is, I don't know, 2 years old, and you haven't update because it was just convenient, right? That's a very tough thing to solve. But it gets worse. Sometimes we try to go clever. Now you say, yeah, no, I have assets that I deploy to a S3 bucket. On my front end, it's vendor from I don't know, those sources. And you create a compatibility layer in the between that says, yeah, I'm going to load those bundles from here, and I'm going to have someone responsible to tell me when to load things. That's OK. That's not bad. I think everyone actually ends up doing this at some point in their own companies. But the problem is, those strategies, they don't scale that well. I mean, they can scale, but it's always small problems that makes our life harder and harder and harder because NPM is slow. You have to sync everyone. You have to publish the dependency, make sure that everyone is running this version of the dependency. If there is, for example, a security breach or something, it's very hard to just go and ask all the teams to update. And same for like customating tools, like they are error-prone. It's very easy to create bugs. They are actually brittle because not a lot of people are using them. So unless that you open source something that gets very popular, probably you're going to run into some mistakes over there. So what's the option? So that's like basically what I'm here for. I'm trying to tell you that we can have performance, so your deployments can be fast. You can do this on build time, which is great, right? You don't have to wait for somebody else. And you can make it relatively easy to share. So what's this black magic, Vitor? So that's the subject of the talk. Like, that's a model federation. And to explain what it is, that's the graph. It's as easy as that. So you just cut the main in the middle, right? And now you're serving from your host application parts of code, and then you have the checkout application being a consumer of those like 2 modules over there. You still have all the domain knowledge. You can do things. You don't have to do a deployment. So every time that the host application updates those packages and serve those like header and footer, the checkout would have the latest version, which is pretty awesome. As you can see, it's much simpler. So in a nutshell, we can share not only modules, but we can share components, functions, data, pretty much almost everything. The most amazing thing, over the wire, so in runtime. And that means that as soon as you update something, you get the final result for everyone. And you can even go as far as having redundancy layers and some self-healing powers. And I'm going to talk about this in the end, but that's pretty cool. So let's explain a little bit of the terminology. So how this works. There is just 2 parts to it, very easy ones. So we have the host application, the application responsible to initialize the Webpack and figure it out how to load the remotes. Usually is the main application that's going to serve as a shell, and then it's going to consume all the remotes. And it looks like this. So, and don't worry if you cannot see it for some reason, but I'm going to show some live coding, and I hope it works. Always tricky with live coding. But basically, on your Webpack configuration, you install the plugin, the module federation plugin, and then you tell the configuration what are your remotes, where they come from, right? Here I'm pointing to localhost, but imagine that you can deploy them to S3 buckets, and you can just serve them from Amazon. And not only that, you can also tell things that are shared between those dependencies. For example, like React. I want to make sure that React only runs in one instance. So if another module actually uses React, we make sure that the versions don't collide, because React doesn't like to play nice with 2 different versions running at the same time. So there is some mechanisms that we can use to prevent that. Then we have the remotes, right? The applications that would just share their code with other hosts. And that's pretty cool because it's almost the same thing. We also install the plugin, and we go through the dependency list. You give a name to it, and you tell which component, function, thing you want to share. And that's pretty much like what you have to do to create this kind of relationship. With that, what you get in return is pretty awesome. So you get dynamic updates. You reduce the overhead. You don't have to do like some environment changes at all. And you can give power to your teams, because basically now what we can have in this example that I showed you is that I have one team working the main application, the host application, and one team very specialized in the checkout, right? But I know what you're thinking. So it's very hard to believe without seeing. And so I tried to prepare a little demo. I hope it works. And it's basically my new company. I'm pretty sure that you never heard about it. It's called Big Bucks. And it's very different. It's a different model. I'm going to sell coffee. The only problem is I'm too addicted to coffee myself, so I might just consume my own product, which is not good for the business, but I'm happy with it. So in this application here, as you can see, we have 2 components. And I can actually show to you this live. So here. Oh, perfect. So I hope you can see. And in this application, just imagine that we have the shopping cart team and we have the checkout team. the application works, right? We have React on both sides. And there's some checkout logic going on. But just imagine that your company goes so big, that now you want to implement different payment methods. You don't want to disturb the shopping cart team because they are working, I don't know, like trying new things, doing a lot of A/B tests. They need to be fast, right? Because this is how the user gets there. They have to show like nice images with amazing background colors, as you can see. And this is how they make money, time to market. They need to be there as soon as possible. The checkout team, though, they only care about, oh, the user going to pay for it? That's the only thing I care about, right? Are we making it easy for the user? It's just one click away from it, you know? And usually, if you have this in a normal configuration, that would be hard. But just imagine for a second that we transform this into a micro-frontend. So let's look at the code, how this looks like. So here, we have a normal like React component, right? Very, very, very simple. As you can see, I already like showed what we have to do to change it. And I have my product list component running here. And if you go to the Webpack config, what I'm doing, the whole setup, is just installing the plugin, telling that, OK, this component here called product list, I'm going to share that, right? And I'm going to run into this port. So I have servers running on my terminal right now, vendoring this. And here's my component, right? We have the product list. It's just a normal component. There's no magic attached to it. Then I also have the checkout component right here, which also exposes just a component. It's just a component with like tailwind. So super simple, very easy into here. I just do some calculations over there. And nice. I also have my Webpack config. It is the same as the other one. And here, on the host application, we have in the main file all the imports. And this is the first nice thing. As you can see here, I am changing my Webpack config now that I'm a host, to tell that I'm going to consume those remotes. So you can see I have something called DSL that we're going to talk in a bit. I have something called product list, checkout. I had an example with Solid. I'm not sure if I'm going to be able to show it, but I think you're getting the idea already. And what we need to do to allow this, well, I have an index file here just importing my whole app, right? So this is running everything in a promise. And here I'm doing the import. So let me change one thing here. So here, now, I'm importing those components from different servers, right? I know that's a bit hard to see this because they are running like one port next to the other. But just imagine that you have an AWS server serving you just the checkout, and another one just serving you the product list. In the front end, that's so transparent that the only thing that I have to do now is just change the name of the components. So I have remote product list, and I can go here and just say, yeah, get the remote product list and the remote checkout. And if I do everything right, and the internet works, what we can see here, if I reload the application, well, it looks the same, Vitor. It's nice that it looks the same, but let's go to the network tab, and I hope that you can see it. If you can't, let me know. If I refresh, now I'm consuming the whole JavaScript code that's attached to the parts of the application over the wire. So we have the module resolution on Webpack running inside this promise, right? So we have the promise. And what we do, we create a graph of dependencies. We analyze those. And here we have all the code that's responsible for every piece of this application being served over the internet. What this means? Well, this means that, well, now if my checkout team, right, decides that, you know what, the name checkout doesn't work too good for the users, we just say buy. Right? Just buy now, like just psychological threat. So what this means is now the product list team didn't do a thing. The application is still running, but if I refresh, I get the latest version of this micro-frontend. So if by any reason also they decide that this is wrong, it's not getting any results, they have the data to analyze this, well, they can revert back and no one was disturbed. It's just getting the latest version of the vendor as you go. So this is pretty amazing, because now I can serve my whole React component, pages, data, everything that I want over the wire. And the host application will get those things on runtime, which is pretty cool. So let's go back to the application. And this is, again, pretty nice, because now you have the control. You can tell when those things will load. Your front end ends up being just the things that you really need, because now you can say, OK, the checkout, they actually have a dependency on style of the components, because legacy application, and we use tailend, but I'm only going to load the checkout component later on when we actually need it. So you have the whole control. We have independent deployments, because now the checkout team does whatever is important just to checkout, and product list does whatever is important just to product list, which is freaking amazing. But then, let me tell you a story, right? That's a true story. I run into this. I don't know how many of you can relate to that. But do you know squircles? Can you show me your hand if you know what this means? Nice, 2 people. That's amazing. So squircle, it's actually a geometric figure. That's not a square, it's not a circle. It's something in between. So it cannot decide what it is, but it exists and looks like this, which is nice. And for some reason, designers really love squircles. So now it's all over the place. Now that I told you, go and look to all your social media, like all the applications that you use every day, you're going to see this everywhere. Basically, we had the square edges. Now everything needs to be smooth, to pass like this idea to the user that everything, it's, like, it's not going to harm you. Like buttons are a little bit rounded. And that's fine, right? Like we figured it out CSS, I mean, to a certain degree. But, I mean, it's not always all flowers or happy dreams. So let me tell you, this was a company that I was working some time ago. The design came to me and said, we have a new design system, we have to change this, and so on. And I look at him and I say, yeah, but do you know that we don't have a centralized design system? I say, yeah, but that's company policy. We're going to have a rebranding. We have to have this by the end of the quarter. And I just run a command trying to find, like, oh, can I figure out where this is coming from? Like, it just keeps looping, because I didn't want to show actually the real files that I found. But I can show the summary of things, which is like we have too many projects. And all of them use different versions of what they understood was the design system. So I don't know, like the sentiment for me was like, yeah, that's fine, that's OK. It's going to be super painful. I mean, I'm going to hate it for sure, but we have to do it, right? Like, we have to do it. Can it be easier? No. So this is what people are calling like the DSL, like the design system library. And if I tell you that we can make a micro-frontend out of a DSL, right? How this would look like? Well, so let me go here back to my code. And actually, where we already have, it's already here. I didn't show you first, but well, the components that I'm getting from another micro-frontend that's called DSL. And this is a very small example, but just imagine a company like GitHub doing this. And they have a team just to support the design system, right? And your whole application list, you have so many internal tools, whatever, they need to use the same branding. And you start to use that. So what happened is, let's imagine that, well, we figured it out that the users really hate our buttons because they are like too scary. And what we can do now, we can go to our DSL, that's right here, and I'm actually serving this button component out of the DSL. Another hint, like I'm using styling components here. You're going to see why. And let's say that now, just to clarify where I'm using it, I just change just the DSL, and the whole application respond to it. You can see like the dot marks here, that those are the components that I'm serving over the wire as well, with the dependency. That's very important. And we can just, like, with one CSS change, now say, yeah, now our buttons are very rounded. Like, the designers will be like, mind blown, right? So you can have, like, even one-on-one with them and show them, like, in real time, like, should we do this? Should we do that? Like, can we do this here, like, this way? It's cool. And that's pretty amazing, because if you do this right, if you centralize your whole architecture around it, then I think the friction in between you changing the code and being compliant with those things, it can be reduced dramatically, right? Well, let's keep going forward. So Another thing that people ask me a lot is, can we share state? Right? That's the most important thing with React applications, right? Yes, we can. We can, and we just need to be reactive, right? So you can use your favorite library, like Redux, Context, RxJS, Zustand. I mean, you name it. Next week, I think there will be like 3 other ones here, and so on, so on, so on. Whatever you feel that's easy for you and for your team. I don't want to be in a way. And actually, I have a little video for you here showing that this is a micro-frontend where the blue dots, it's a React component. Everything that's in yellow is just JavaScript. Everything that's in red, it's Svelte. And the store itself, it is a micro-frontend. So all of those technologies, they're talking with the same store, right? I create a Redux store. It could be any other framework. I put in the micro-frontend. I distribute over the wire. And we have synchronized state and with all the even different frameworks. And you could tell me, that's nice, but why you want to have different frameworks in the same page? Well, just imagine that you're, for example, airline company, right? Every hour, the amount of money that you make, it's insane. Just imagine having to stop to try a different framework, right? You want to adopt, you have a big legacy system, you cannot just go bulldozer and just replace things. You have to make space for new things. So with micro-frontends, you can do like incremental adoption. You can still have your system running, and by creating some smart contracts in terms of like how your data communicates, if it's events, whatever actually you wanted to do, put in the micro-frontend, now you have separation of concerns, and you can, in runtime, right, test those things, change frameworks, do your benchmarks. A/B test is amazing with this. So I think that's very, very, very powerful. Cool. So I have one more thing that I have to tell you. It gets better, because it doesn't stop there. Actually, there's so much more that I could talk, but I don't have the time. But I really want to cover like 2 more points that I think they're amazing, which is the self-healing capabilities. And to explain to you what is this, just imagine, right? We have a bunch of micro-frontends. They all have dependencies. They can like import different libraries as well. And what happens when one of those libraries are missing, right? You have a design system, you using styled components, then you decide to go with all the library. You don't put this into Webpack config, or you don't tell the host that this is a shareable asset, they should look for it. What did you do? Well, the funny thing about it is that since we can see the whole graph of dependencies, the whole module graph, we can go to the next micro-frontend and ask, do you have this dependency? Like React is missing here. Can you vendor for me? And you can do this with the next one and the next one until you find it. So you can go through the whole tree and figure it out how to load those things, right? But it doesn't stop there, because another question that I got a lot is like, OK, Vitor, I saw that you describe all the front ends that you're loading in runtime. That's nice. But if I don't know yet what I'm going to learn, like if I don't know yet what I'm going to load, can I do this? Well, this other example is about dynamic federation, which removes the Webpack config need and lets you to actually interact with the Webpack API directly to, in runtime as well, tell that you're going to load different scripts, right? And to not make this too abstract, let me show you. So what I'm going to do, I have other servers running here, and I'm going to stop all my micro-frontends here for a second. And I have another project here that's also running a DSL. And nice. And let me just take the dark mode, because that's not nice. Cool. So here I just create a very, very simple micro-frontend. It's just a button. Just a button. And I'm using CSS over there. It's a button. It has a counter, and so on. Everything is the same. And I have my host application, which just imagine that You're working in the Black Friday, right? You have an e-commerce. This is also like the best page of your whole application that converts users. And that's super important. And time is money, right? OK, so here, we are loading this button from our DSL. But there's a problem. I put a bug in the code. I wasn't paying attention. And it turns out that if I click too much, if I buy too many things, the application breaks. And I'm not taking this into account. And well, as I told you, time is money. If this is what the user sees, I think no one's going to buy anything, right? So depending on the size of your responsibility, this can be a very, very big problem. Imagine Amazon running out of buy buttons. That's a big problem. So let's see what happens, actually, if I put this live. So OK, we can count to 4, right? So 1, 2, 3, 4. And now we're going to introduce the same bug. I'm loading this micro-frontend over the wire. But look what happens now. So what happens here is, I didn't show you, but I have 2 versions of this micro-frontend, which is my DSL, and the first one was blue. Let's say the previous version, the stable version, the battle test version. And I didn't tell my application that to load this first. It just loaded the one that I was supposed to get. But it default to it immediately, trying to figure it out, OK, there is a bug here. I hit an error boundary. I'm going to just default to the stable version. And to show you how this works, I can quickly go here. And I can show you in the code. Basically, what we have, I create a hook on React that's interacting with the native API on Webpack, right? I think you can see this, right? And it's trying to figure out the module. So here we have this use dynamic script. So what I'm trying to figure it out is, OK, if there is any error in this component specifically, I have a fallback URL that I can get from Amazon, anywhere that you want to stat your static JavaScript. And I'm just loading this into the page. And because those assets get cached, I don't have to load it twice. So that's basically what I'm doing. Here, I'm actually forcing you to, if I reload, I get the previous version because it was a demo, right? I wanted to show you how this works. But you can increment this further and further. And the application itself, I have just this error boundary here where I can tell you, OK, if there is a bug, I trust that this module here works because I tested this before. And I can put this information here and just forget about it. Right? If there is any bug, I still log into Sentry or any other tool. I can get this running, and I can default to a previous version. So my application kind of fix itself on the fly, which is nice. And just imagine this even further, because you put this as an environment variable, something that you can control from the outside, and you can make things even more flexible. So it unlocks a lot of possibilities. Of course, with a lot of responsibility, because it's not all flowers. There is a lot of downsides as well. But here is up to you to control your application and how you want to load those scripts. And the nice thing is, also didn't show this, my DSL here, it shares with my main application styled components. And my main application forgot to include this as a shared asset. But since I had someone else in my package JSON that really consumes it, I got the self-healing capabilities of someone down the line of vendors telling me, oh, I have the styled component dependency. I'm going to send to you, and your application can work. So with this example, I kind of combined both, so I wanted to show you this. And this is pretty much all the superpowers that we can use to create those dynamic applications. So I showed you the code already. And yeah, there is so much more that I cannot cover here. And I ask you again to follow me on the social media, because there's so many, how you do error handling, how you do handle TypeScript, how you do vendor types. Those are valid questions. How you put this in production, how you control React versions that run in parallel, and so much more. So if you got excited, come to talk with me. I will be super happy to chat with you. And one last thing that I would like to ask before I go is to take a picture, all of you. So like Eric, it's a very nice idea. I would like to make a selfie with all of you. So first of all, thanks a lot to be here. And so let's do this. I'm going to try to not be awkward, but let me do a countdown. It's like 3, 2, 1. Oh. No, can I? Please, again. Sorry. 3, 2, 1. Yep. So thanks a lot, everyone.